In the last video, we talked about variables and ownership. We discussed how when you assign one variable to another, ownership is moved unless you explicitly call the clone method. With the exception of some primitive types that are stored completely on the stack, such as integers, floating point numbers, booleans, and characters, which when assigned to a different variable are cloned. In this video, we'll discuss ownership in the context of functions. First, we'll create a function called printString. PrintString will take one parameter called p1, which is going to be of type string. Then inside the function, we'll simply print out p1. In main, let's comment out line 3 and see what would happen if we pass s1 to the printString function. On line 6, we see a familiar error stating that s1 cannot be borrowed after it has already been moved. Passing a variable into a function has the same effect as assigning one variable to another variable. When we assigned s2 to s1, ownership of this string was moved into s2. When we call printString and pass in s1, ownership of this string is moved into p1. p1 lives within the printString function scope, so at the end of the function, p1 is dropped and the string on the heap is cleaned up. Because s1 is moved into the printString function and the new owner of this string is now p1, s1 is invalidated, so it cannot be printed out on line 6. Just like the variable assignment on line 3, one of the ways to fix this code is to clone s1. This code works because instead of moving ownership of s1 into p1, we first clone s1 and then move ownership of that cloned string into p1. At the end of the printString function, p1 will be dropped, so the cloned string will be cleaned up. So far, we've seen how ownership can move into functions. Next, let's look at how ownership can be moved out of functions. We'll create a function called generateString, which takes no parameters and returns a string. Then in main, we'll create a new variable called s3 and set it equal to a call to generateString. Then we'll print out s3. Let's run our program to see what happens. As we can see, s3 is the string Ferris. In this case, generateString is creating a new string with the value Ferris. When the string is returned from the function, ownership of that string is transferred to s3. s3 will be dropped at the end of main, and the string on the heap will be cleaned up. Now that we've seen how ownership can be moved into a function and out of a function, let's talk about how functions can take ownership and give it back. We'll create a function called addToString. It will take one parameter, which will be a string, and it will return a string. Inside the function, we'll append isAwesome to p1 and then return p1. To append to the string, we use the pushStir method. Also, we get an error here stating that we cannot borrow p1 as mutable because it is not declared as mutable. To fix this error, we simply have to mark p1 as mutable. This function takes ownership of a string, mutates that string, and then returns ownership of that string. Let's use this new function in main. First, we'll uncomment line 3, and then create a new variable called s4. And we'll set it equal to add to string and pass in s2. Finally, we'll print out s4. Let's go ahead and run our program. As we can see, s4 is Rust is awesome. On line 3, we declare a variable called s2, which is going to be a clone of s1, the string Rust. Then on line 6, we declare s4, which is going to call add to string and pass in s2. At this point, ownership of the value inside s2 is moved to p1. We then append isAwesome to the string and return p1, which moves ownership out of this function into s4. At this point, s2 is invalid and s4 has ownership of the string, so we can print out s4. The last thing we'll look at is stack-only data types. Let's create a new function called printInteger. Then let's use this function in main. Notice that even though we're calling printInteger and passing in x, we can still print x on line 15. On line 13, when we create y and assign it to x, the value of x is cloned. Similarly, when we call printInteger and pass in x, the value of x is cloned into I. So because ownership is not moved, we are able to print x on line 15. And again, this only works for primitive data types that are stored completely on the stack, such as integers, floating point numbers, booleans, and characters.